on screen are called real image. For example, when the image is forming in our mobile, in laptop, okay, in a screen of smart glass, called real image. Then those images which formed on a screen are called real image. And what is virtual image? The image which does not form on a screen, okay, which form inside of the mirror, okay. The image which formed inside of the mirror are called virtual image, okay. So there are two types of image. One is real image which formed on a screen, and what is virtual image? The image which does not form on a screen, okay, and it form inside of the mirror, called virtual image. Now, image formation in a plane mirror. Image formation in a plane mirror. Plane mirror. Firstly, what do you mean by plane mirror? Plane mirror. A mirror which reflecting surface is plane. Simply from this name, plane mirror. A mirror which reflecting surface is plane is called plane mirror. If we do silvery coated of a glass, okay, of a transparent glass, then it can be formed a plane mirror. So here, let us suppose an object is present here, a point object is present here, O object is present here, and we want to make the image formation in a plane mirror, okay. What is the necessary case for image formation in a mirror? When two reflected ray will intersect to each other, okay, when two reflected ray will intersect to each other, then image will formed, okay. When two reflected ray will intersect to each other, then their image will formed, okay. So here, let us fall one incident ray is perpendicularly on this mirror. So we will see it will reflect back in same way, okay, because here angle of incidence and angle of reflection both are 0 degree. You will say, why it is 0 degree? It is 90. No, angle of incidence and angle of reflection will be 0 here. Why? What do you mean by angle of incidence? The angle between incident ray and normal is called angle of incidence. And what is angle of reflection? The angle between normal and reflected ray, okay, is called angle of reflection. But incident ray, reflected ray and normal both are in a single line. Then angle of incidence and angle of reflection both are 0 here, okay. Now, another ray is falling on the mirror obliquely from an angle which is less than 90 degree. Then as we know, according to the law of reflection, the ray of light will reflect back with same angle, okay. Here angle of incidence will be equal to the angle of reflection, so by same angle it will reflect back. And as here we are looking, these reflected ray can never intersect to each other, okay. These two reflected ray can never intersect to each other. So how can image formed here? We can see the image of any object inside of the mirror. Then how it is possible? So we will put this reflected ray in the backward direction from imaginary line, okay, from this imaginary line called virtual line, okay, and then we can see they can cut to each other. Virtually they can cut each other, okay, and where both reflected ray are cutting, virtually their image will formed, okay. So image is forming here. Then what is the nature of image? This will be virtual image, okay. This will be virtual image. Why? Because the real reflected ray is not cutting here, okay. It is cutting virtually. If the ray of light will not cut in a real way, then the image formed will be virtual, okay. Here these reflected ray are cutting virtually, so the nature of image formed will be virtual. Now, characteristics of image. Characteristics of image in a plane mirror. okay, in a plane mirror. What is the characteristic of image here? The image will form beyond the mirror, okay, the image will be formed beyond the mirror, okay. Then in first case we will discuss about the position of image, okay. So beyond the mirror at same distance of object, okay, beyond the mirror at same distance of object, means the distance from mirror to object is called object distance, and it is represented by u, okay, and the distance from mirror to image is called image distance, okay, and it is represented by b. So here the image is forming beyond the mirror and its nature will be virtual, okay, so its nature will be virtual. One more thing I just want to clear here, virtual image will be always erect, okay, erect, and real image will be always inverted, okay. So here virtual image is forming and it is erect, then virtual and erect image will form. You can see, you can stand in front of the mirror and you can see your image, it will be erect, okay, erect. So we can see here virtual and erect image will form. In next case, same size of object, okay, the image formed will be of same size of object, same size of object. Next, it shows the property of lateral inversion, means laterally inverted, okay. It shows the property of lateral inversion. What do you mean by lateral inversion? When we see our right hand inside of the mirror, then it appears left, okay. When we see our right hand inside of the mirror, then it appears left, and when we see left hand inside of the mirror, then it appears right. You can see, suppose we are standing in front of a mirror, okay, and we are raising our right hand, okay. So we can see in this way image will form, okay, image will form inside of the mirror. So this is my right hand, and what will be image? This will be left, okay. And let us suppose if we are raising our left hand inside of the mirror, in front of the mirror, so the image formed will be in this way, okay, and this is our right hand. So we can see, when we see inside of the mirror our left body part, then it appears right, and when we see right part of our body inside of the mirror, then it appears left, and this property is called lateral inversion, okay. So guys, there are two types of mirror. First one is plane mirror, which I have already discussed here, okay. Plane mirror, which reflecting surface is plane, okay. It is a type of mirror which reflecting surface is plane, called plane mirror. Next one is curved mirror, okay. Curved or spherical mirror, okay. Spherical mirror. It is a type of mirror which reflecting surface is spherical, okay, or curve. It is a type of mirror which reflecting surface is spherical, called spherical mirror, and the mirror which reflecting surface is plane, called plane mirror. So there are two types of spherical mirror. Okay, there are two types of spherical mirror. First one is concave mirror. Concave mirror. Okay. First one is concave mirror, and second part is convex mirror. Convex mirror. So there are two types of spherical mirror. First one is concave mirror, and next one is convex mirror. As it is just like a plane mirror, we can see those mirror which reflecting surface is concave. Okay, the mirror which reflecting surface is concave called concave mirror, and the mirror which reflecting surface is convex is called convex mirror. I just want to clear one thing. Suppose this is a curve. Okay, so the inner part of this curve means this part is called concave part, concave, and this part of the mirror is called convex mirror, or this part of the surface is called convex. Okay, so if the reflecting surface of the mirror is concave, okay, if reflection takes place from here, so this type of mirror is called concave mirror, and if reflection takes place from the convex surface, so this type of mirror is called convex mirror. I am going to make a neat diagram here. For concave mirror, the mirror which reflecting surface is concave means convex part will be polished. Okay, so the mirror which reflecting surface is concave is called concave mirror. Okay, and axis which divide this mirror into two equal part is called principal axis. Principal axis. Okay, the point from which this mirror is dividing called pole, which is represented by P. The center from which this curve will be made called center of curvature, and between center of curvature and pole there is a point called focus, and this principal focus divides this distance into two equal part. Okay, so what is the characteristics of concave mirror? When the parallel beam of light fall on a concave mirror to the principal axis. Okay, when two or more parallel beam of light to the principal axis fall on this concave mirror, they will converge on its focus. Okay, they will converge on its focus. This is the property of concave mirror. If parallel beam of light fall on a concave mirror, then they will get converge on its focus. Okay, so concave mirror is also known as converging mirror. It is also called converging mirror. Okay, next one is convex mirror. What do you mean by convex mirror? The mirror which reflecting surface is convex called convex mirror. So what will be the polished surface? It will be concave. Okay, polished surface will be concave and reflecting surface will be convex. So here will also a center of curvature, here will be focus, principal focus, and here will be pole. So what is the characteristics of this convex mirror? When a beam of light parallel to the principal axis fall on a convex mirror, then it gets reflected from the focus, or you can say it get diverge from its focus. Okay, in this way. Therefore, this mirror is also known as diverging mirror. Okay, so convex mirror is also called diverging mirror. So there are two types of spherical mirror. First one is converging or concave mirror. Okay, and second one is diverging or convex mirror. Now we are going to teach you the rules of image formation in a concave mirror. How to image formed in a concave mirror. I am just going to discuss here. This is very important for image formation. Okay. So you can see here rules of image formation. Rules of image formation in a concave mirror. Okay, concave mirror. Rules of image formation in a concave mirror. First rule: when the ray of light fall parallel to the principal axis on the reflecting surface of a concave mirror. Okay, let us suppose this is a concave mirror. When the parallel beam of light fall on it to the principal axis, then it will reflect from its focus. Okay, it will reflect from its focus. This is first rule. When parallel beam of light fall on a concave mirror, it will get reflected from the principal focus. Next factor is what? Next rule is what? Okay. Next rule is conversion of first rule. When a ray of light fall from the focus to the concave mirror, then it get reflected parallel to the principal axis. Okay. Next rule, third rule is what? When the ray of light fall obliquely on the pole. Okay, when the ray of light fall obliquely on the pole, it get reflected with the same angle. Okay, with the same angle. This is center of curvature, this is focus, this is pole. If the ray of light fall obliquely on the pole, it get reflected with the same angle, means angle of incidence will be equal to the angle of reflection. And last rule is what? Fourth rule: when the ray of light fall from the center of curvature on a concave mirror, okay, this is center of curvature, this is focus, and this is pole. Okay, then when the ray of light fall from the center of curvature to the concave mirror, it gets reflected back in same way. Okay, in the same path. Then one thing is clear here: in each and every rule, law of reflection is following. Okay, you will say how here law of reflection is following in this rule, in this rule. How a law of reflection is following? Okay, only in this rule law of reflection is following? No, in each and every rule, law of reflection is following. Okay, you can see here, as we know, the radius of a sphere or the radius of a circle will be always perpendicular to the surface. Okay, so from the distance from center of curvature to the pole is called radius of curvature. Okay, this is called radius of curvature, and this radius will be perpendicular to the surface. Here, 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 means at each and every point of the surface to the center of curvature. Okay, the line will be perpendicular. So as we know, angle of incidence and angle of reflection is what? The angle between incident ray and normal. Okay, the angle between incident ray and normal is called angle of incidence, and the angle between reflected ray and normal is called angle of reflection. So in this case also we are going to draw this normal, this imaginary line. As we know, from the center of curvature to this point of incidence, the line will be perpendicular. So now you can see here angle of incidence is equal to the angle of reflection. Okay, so in first rule, law of reflection is following. It is clear. In same way, here is also law of reflection is following, means angle of incidence is equal to the angle of reflection. In third rule it is clear. Okay, angle of incidence is equal to the angle of reflection. And in fourth rule, as we can see, it form on the mirror perpendicularly, because the distance from the center of curvature to the surface is perpendicular, and so it will move in the same way. Okay, so here also angle of incidence is equal to the angle of reflection. So from these 4 rules, only 2 rule will be applied to form the image in a concave mirror. Okay, and where the 2 reflected ray will intersect to each other, their image will be formed. Okay, the place where 2 reflected ray will intersect to each other, their image will be formed. Now you can see here how many possibilities are there to form image in a concave mirror. Okay, then the image formation in a concave mirror. Image formation in a concave mirror. There are 6 possibility of image formation in a concave mirror. What is main possibility? You can see here. First thing, this is center of curvature, this is focus, this is pole. Okay, in first possibility, object can be placed between F and P. Okay, object can be placed between F and P. In second case, the object can be placed at F, at the focus. Okay, the object can be placed at focus. In third case, object can be placed between C and F. Okay, between C and F, object can be placed. In fourth case, object can be placed at C, at center of curvature. Okay, and in fifth case, object can be placed beyond C. And in last case, which is sixth case, in that case, object can be placed at infinity. Okay, so there are 6 cases of image formation in a concave mirror, from which I am going to discuss this first case. When object is placed between F and P. Okay, when object is placed between F and P, means between principal focus and pole, then we can see here, let us suppose this object is placing here AB. Okay, so we will apply only 2 rules for image formation in it. So from first rule, when the ray of light fall on a mirror parallel to the principal axis, then it will reflect from the focus. Okay, it will